Hi, Geometry. This is page 7 of our packet, and I want to talk to you about a new unit of measurement called a radian. So there was a radian video that we watched together in class. It's also in our folder. Please watch that if you were absent from class and you haven't seen it yet. It describes about what is a radian. And from that video, we learned that it takes 360 degrees to go around in a circle. And that's equivalent to 2 pi radians. And so we could set up an equation that says 360 degrees is equal to 2 pi radians. If I divide both sides by 2, I get 180 degrees equal pi radians. That becomes our conversion factor that we're going to use to convert from degrees to radians. Moving down to our bottom of this page of notes, there's also another support video in our folder about converting degrees to radians that I encourage you to watch for extra help and support. So we know 360 degrees is the same as 2 pi radians. Let's write that in here. So when we start going around our circle in degrees, we have 0 degrees, 90 degrees, 180 degrees when I've gone halfway around my circle, 270 degrees when I've gone 3/4 the way around my circle, and 360 degrees when I've gone all the way around my circle. So we learned in the video that if I start at 0 radians and I go all the way around my circle, I get back to 2 pi radians if I go all the way around. So halfway around would just be pi radians, and then half of that distance would be pi over 2 radians. And then at 270 degrees, I would have gone 3 pi over 2 radians in distance. So how can we convert all these degrees around our circle to these radians if we're not sure what they are? Well, we can use the fact that 180 degrees is the same as pi radians. And so to convert from degrees to radians, we take the number of degrees they tell us, and we multiply by the conversion factor, pi radians over 180 degrees. Conversely, 2 pi radians is the same as 360 degrees. So pi radians is the same as 180 degrees again. So if we're given radians, we take the radians that we're given, and we multiply by 180 degrees over pi radians. These two conversion factors are what we use to change our units from degrees to radians or radians to degrees. So let's flip our packet to the next page and look at some specific examples. So at the top of the page, numbers 1 through 8 are all degree measures that we're converting into radian. So when we want to convert degrees to radians, we're going to use our first box. That means we're going to take the number of degrees and we're going to multiply by pi radians over 180 degrees. So let's see what that looks like in a problem. Let's do the first problem, 210 degrees. So we're going to take our 210 degrees and we're going to multiply by pi radians over 180 degrees. So I'm going to show you in class how you can use your calculator to do this fraction simplifying. It's a little more difficult via my iPad. So we're going to simplify this. Let me get a different color. In the numerator, if I multiply 210 times, this is like 210 over 1. If I multiply this, I get 210 pi over 180. When I simplify 210 and 180, when I simplify both by a factor of 10, then I get 21 over 18. 21 over 18 both have a factor of 3. I'm going to reduce by 3. 21 divided by 3 is 7. 18 divided by 3 is 6. this is really 7 times pi in the numerator all over 6 when I reduce, and this is radians, R-A-D. Sorry, let me erase that. We tend not to write radians as our unit as we learn how to do more of these problems, but for right now I'm going to leave that. So let's take a look at another one. Let's take a look at number 6, 36 degrees. So again, I start off with my 36 degrees and I multiply by my conversion factor. That would have degrees in the denominator, so they cancel, and pi radians in the numerator, so I'm left with a radian unit. So let me grab a different color. Again, my degrees cancel, and my 36 is in the numerator, so when I multiply them, I get 36 pi all over 1 times 180, or 180 in the denominator. 36 and 180 both have a factor of 9. So 36 divided by 9 is 4, and 180 divided by 9 is 20. But even as I do that, the 4 and the 20 have a factor of 4. So I'm going to reduce by 4 again, and I get 1 and 5. So this looks like it's 1 times pi, or pi on top, and the denominator is 5. 5, this is pi over 5 radians. If you're having a great difficulty simplifying the fraction, and you were not in class, please come to office hours and I can show you how your calculator can help you simplify your fraction if you're having a lot of difficulty doing that. So let's take a look at a couple examples of converting radians to degrees. So this is going the other direction. I have radians and I like to convert them to degrees. So when I do radians to degrees, I'm going to take my number of radians and multiply by 180 degrees on top and pi radians in the denominator. That's so my radian unit will cancel and I'll be left with degrees. So let's take a look at what that looks like. We'll start with number 9. So I take the radians that they give me and I multiply by 180 over pi, 180 degrees over pi radians. When I do that, my pi's cancel. That's really nice. And 6 and 180 both have a factor of 6. So let's reduce by 6. And when I reduce by 6, 6 divided by 6 is 1. And 180 divided by 6 is 30. And so my pi is canceled. So I'm left with 30 degrees as my final answer. Let's take a look at another problem. Let's do number 11. So I have 7 pi over 3 radians. I'm going to multiply by my conversion factor. That's 180 degrees over pi radians. So I'm going to cancel from my numerator to my denominator. I'm going to cancel my pi radians. This gives me 7 times 180 on top. So I multiply 7 times 180 on my calculator, divided by 3 in my denominator, and I would get 420 degrees for my answer. Let's take a look at number 16, shall we? Number 16, I put a star by. This is radians, but it doesn't have a pi in the problem. The pi is multiplied in. So this 2 pi, 2.5, is a radian, and pi has been multiplied inside of it. My 3.14 is multiplied in it. So when I set up my conversion, it's a radian, 2.5. So to change it to degrees, I'm going to multiply by my 180 degrees over pi radians. So my radians cancel. This is 2.5 radians, so my radians are going to cancel. Notice I don't have a pi to cancel. This is completely done on my calculator. I multiply my numerators. So I would do 2.5 times 180 on my calculator. Please do that at this time. And then divide by pi on your calculator. You should get approximately 143.23 degrees. So this would be my answer. This is how I would handle it if I didn't have a pi to cancel. I hope this was helpful. If you missed class and you need more support than these notes, please don't hesitate to come to office hours. Thank you.